This is about 8.2 in the review problem set that is from 43 to 59. To solve the problem, it is important to remember the formula, the pattern of the equations. For cardioid, it looks like R equals A plus or minus A sine or cosine theta. What's important here is there are two terms, and sine and cosine are involved, and the numbers are the same. When that is horizontal cardioid, the pattern of the graph looks like this, and that is associated with cosine. Vertical cardioid looks like this, and that is associated to sine. The next pattern of the equation we learned was the equation of rows. In equation of the rows, we have only one term, and this n multiplied to theta determine the number of petals. The pattern will be decided by even or odd. When this multiplied number is odd number, the number of petals and this multiplied numbers will be the same. Therefore, if n equals 3, then you will see only 3 petals. And if n is even number, then the number of petals will be twice of n. So when n equals 2, you will see 4 petals. What is interesting is when n equals 1, that means there is nothing appears in front of sine or cosine. So the pattern of the equation looks like this. This is rows with one petal. That one petal is indeed a circle. When that is associated with cosine, the circle is attached to x-axis. When that is associated with sine, the circle is attached on the y-axis. You can verify it. You don't really have to remember clearly. Other important thing you have to remember is for those patterns of equations, the circle passes the origin. That means the center is not at the origin. When we consider the circle with center at the origin, the equation will go like R equals A, because the circle, the distance of the circle from the origin will be the same toward any direction. The last pattern we learned was the limaçon. Limaçon has an inner loop. It is like a cardioid. Indeed, it is a generalization of the cardioid. In limaçon, we have two terms, and the A and B doesn't have to be the same. When A equals B, we called it cardioid. When that is a straight line which passes through 0, 0, the pattern of the equation is theta equals A, because that just means the angle is always A. Indeed, A is a radian measure of the angle in this case, regardless of R. That means the distance from the origin. So this is positive distance and this is negative distance. When you convert this pattern of the polar equation to the rectangular equation, this theta gives us the slope related information. So all you have to do is tangent inverse of theta times x. Number 55 is about r equals cosine of theta minus 1. So 1 and 1, that is cardioid. And that is horizontal cardioid. Just to make sure we evaluate. So theta equals 0, then r equals cosine of 0 minus 1, which is 1 minus 1 equals 0. Everything passes 0, but these 2 doesn't. So I will cross that out. Theta equals pi over 2, then r equals cosine of pi over 2 minus 1, which is 0 minus 1, which is minus 1. This time we have to go opposite. So pi over 2 is here. We go opposite, and we have to plot at the distance 1. So it should pass -1. Therefore, this is the answer. But in this case, as long as you remember the pattern, then you can just directly choose this one, because this is the vertical cardioid, cosine is involved. So this one is the only possibility. But it is much, much better to check with the value. So angle, plug in angle, and calculate the distance from the origin. If distance is positive, then go toward the angle direction. But if distance is negative, then you go to the other direction of the angle. Number 56 is about rhos. R equals 2 sine of 2 theta. This is a rhos. This is an even number. What I said was, when that is an even number, the number of petals is double of this number. So 4 petals. So as long as you know this, you can choose this immediately. But if you cannot remember it, then you have to plug in some angle values and try to figure that out. But in this case, it'll be a little bit harder to do it because there are leaves and there are angles where the distance will become 0 more often than other problems. The next problem is r equals 2 cosine of 3 theta. So this one, again, one term, so that is rhos with petal, 3 petals. Why is that? Because this one is an odd number. We have only one option, and so we can immediately choose the answer. Number 58 is about r equals 3 sine of 5 theta. Only one term with odd number multiplied to the angle. Therefore, that is rhos with 5 petals. If that is odd, then number of petals is the same as the number multiplied. If this is the even number, then you have to double it. So it should have 5 petals. And 1, 2, 3, 4, 5, everything has 5 petals. And so it doesn't give us clear information. So I will evaluate at certain points. So when theta equals 0, r equals 3 times sine of 5 times 0 equals 3 times sine of 0. This is 0, so that is 0. So theta equals 0, that must be 0. So, but the distance is 3. But we, in this case, we have to be careful because it can be from the other direction. So we have to evaluate more. Theta equals pi over 2. Then r equals 3 times sine of 5 over 2 pi. So this one is coterminal with pi over 2, because when you add 4 pi over 2, it becomes 5 pi over 2. So that is 3 times sine of pi over 2. Therefore, 3 times 1 equals 3. So toward pi over 2, that must be, the distance must be 3. So obviously, the even if there could be we evaluated 3 pi over 2, the point must stay in this vertical line, but this doesn't have any intersection. So I will cross this out, and I will cross this out. And so the only possibility is stage 2. But when pi over 2, theta equals pi over 2, it should pass the point whose distance toward pi over 2 is 3. The only one that satisfies the condition is this one. Right, so we can cross this out. So this one is the answer.